This is section 9, derivatives of inverse functions, example 1. So when we're talking about inverse functions, hopefully you remember how to find an inverse function. You swap x and y and solve for y. Now, we're going to go through a similar process when we find the derivative of an inverse function. And the first thing we're going to do is swap x and y. Then we're going to find the derivative implicitly. And the reason we're going to do that is because the y is now going to be on the right side, which is where the majority of the equation ends up being. So it's going to take a little bit more work to find the derivative. Then we plug in the appropriate y value, most likely, because that's what's going to be in the equation, and we'll have our answer. So let's go ahead and do this. So the first thing we do, like I said, is swap x and y. So this is now x, so it's x equals 2y cubed plus y squared minus 1. We take the derivative implicitly because clearly we're dealing with y, and we know that y is a function of x, so we cannot just take it explicitly. So 1 is going to equal 6y squared dy dx plus 2y dy dx. Now there's a dy dx on both of the right terms, so I'm going to take it out. Get 6y squared plus 2y. And now we solve for dy dx by dividing. Now if they just asked you for the equation of the derivative of the inverse function, this would be it. However, it asks you to find the derivative of the inverse at the given x value. It says to find it where x equals 2, which means that we need to find, because our derivative is in terms of y, we need to find what y is when x equals 2 in our original inverse function. So we're going to say that 2 equals 2y cubed plus y squared minus 1. All right, so we need to find the y value that satisfies this equation. And you might be thinking, oh my gosh, how am I going to do that? It's a cubic function, there's only 3 terms, I can't factor, I can't do these things. However, you can kind of use some common sense. If you have number sense, and hopefully at this point you kind of do, you can figure out a y value that would make this statement true. If you have no idea, just try stuff. Right? Does 0 work? Well, if y is 0, then 2 equals negative 1, so no, that doesn't work. What about 1? Well, if y is 1, 1 times 2 is 2, plus 1 is 3, minus 1 is 2. So that does work. So y equals 1 is going to be the number that I plug in, because when y equals 1, x equals 2. It's the number that satisfies that requirement. So I'm going to evaluate this when y equals 1. Which means I get 1 over 6 plus 2, which is 1/8. Okay, so if I give you a problem like this on a test that's non-calculator, it will be as easy as that to figure it out. Okay, let's do example B. So again, we swap x and y. So x equals e to the 4 minus y minus y. We take the derivative implicitly, so 1 equals. Now, the derivative of e to the 4 minus y is negative e to the 4 minus y. Remember, we used the chain rule, dy dx, minus dy dx. Again, both terms end up with dy dx in them, and that's normally going to happen. So we take it out. And dy dx equals 1 over negative e to the 4 minus y minus 1. And so again, our job is to figure out, well, if x equals 3, what do we get? So negative 3. So if that's negative 3 equal to e to the 4 minus y minus y, okay? Well, in order for x to even be a whole number by itself, e would have to go away. And the only way for e to go away is if y is 4. So if y is 4, then we have 1 minus 4, which is negative 3. So y equals 4. That's the only thing that would satisfy this. So we plug in 4. So we get 1 over negative e to the 4 minus 4 minus 1. Well, 4 minus 4 is 0, which makes that 1. So we get 1 over negative 1 minus 1, which is negative 1/2. And that's the answer. Now, sometimes it won't be so obvious what that number ends up being, and then you'll be allowed to use a calculator. So, in part C, we're doing it again, swapping x and y. X equals y cubed minus 4y squared plus 7y minus 1. We take the derivative. Now, you've seen that when you take the derivative, you're going to end up with dy dx and all of your terms on the right side. So I'm just going to jump a step, if that's okay with you, and go ahead and pull out dy dx. So now when I take the derivative, I'm just putting the derivative on the inside. So we get 3y squared minus 8y plus 7. Of course, the derivative of negative 1 is 0, so we don't have to worry about that. And then we divide, so dy dx is going to equal 1 over 3y squared minus 8y plus 7. Now, I still need to figure out what y value I would use if x is 1. So if 1 equals y cubed minus 4y squared plus 7y minus 1, and I try stuff, well, even if I plug in 0, it doesn't work because 1 doesn't equal negative 1. If I plug in 1, I get 1 plus 7 minus 5. That doesn't equal 1. So that doesn't work. So I'm going to plug this into my calculator, and when I do, I'm going to get that y equals 0.349. Now, if you don't remember how to solve something like that on your calculator, remind me in class to go over it. So then I'm going to plug in y equals 0.349, and when I do, I just get a number, and that ends up being 0.219.